All right, so homework number 2. Let's jump in. Oh, that's the wrong one. That's why we want this. Okay. But we want to graph the quadratic equation here. So we can use the vertex formula for number 1, but an easier way is to just use transformations. So y equals t squared minus t squared, let's say. We all know it just looks like this. So y equals minus t squared plus 4 is just up 4 units. So your vertex is going to move from the origin to up here and then go down. So this is going to be 0, 4, your vertex. And then this one is down 1 over 1, and this one's down 1 over 1 as well. So this would be, say, 1, 3, and minus 1, 3. So probably those 3 points is enough. Let's click the parabola shape. I don't know. All right, I'm not great with this graphing tool yet. Graph layers, I don't know what that means. All right, the coordinates of the vertex we just said 0, 4, so we don't use that much. Let's click this thing and maybe click a dot. How does this work? I know I've graphed stuff on here before. So normally you pick the shape. It's not a circle, it's this guy. Okay, there we go. There we go. And we have the parabola. So you only need 2 points there. It does the third point for you, and all set. Okay, write an equation for the given quadratic function. Give your equation in the form. Oh yeah, so this one's a little bit tricky. Basically, they want us to complete. Oh, they give us the points though. Okay, I thought they wanted us to do something more complicated. So let's say if you know the vertex, and let's say it's h comma k, then y equals a squared plus bx plus c may be written as y equals a times x minus h squared plus k, where hk is the vertex. Yeah, so this is known as the vertex form, which is different than the vertex formula. So this h is like that negative b over 2a we were talking about. So let's say vertex 1, negative 3 in my example, and y-intercept of 0, minus 5 would look like y equals okay, so it would be a times x minus 1 quantity squared. Oh, that's not the vertex. This is plus some. Is it the vertex? I can't remember. There's a problem here. Yeah, so this is not going to be k. This is going to be something generic, like I don't know, plus some constant. I need to pick another letter. Not k. It won't be the y-intercept, because the problem is when you multiply this out, you'll have a times h squared, so that'll give you something else. So let's just call it plus some garbage. I don't know. Let's say just plus d. I don't know. So what you do, let's say we have this plus d thing. What we do is we just plug in 0, negative 5. Why am I getting I'm getting confused for some reason here.
Yeah, I got confused on this one too.
It's all right. It's all right. I didn't go over this explicit. I went over the vertex formula because that's usually all you need. So the thing is, we need to solve for the different letters. The vertex. So there is a vertex form. I thought it was y minus. I don't know. Why don't we Google it since I'm getting forgetful. Let's say vertex. That's a thing. Yeah. So I just want to know what the vertex formula is. We could look it up on our graph, but see, the negative b over 2a is what I taught you guys, which is the normal thing, but this is not what I'm looking for. All right, let me just think about it for 1 second. I'll be able to come up with it. So we know this. We know that this is definitely the x coordinate. My only problem is I want to plug in the second point, right? 0, -5, but then I'll still have 2 letters left, so that's no good. Okay, so let's try and just use the vertex. Maybe I'm taking the wrong approach here. I'm definitely taking the wrong approach. I'm being dumb. I know what's wrong. Let's not use the vertex formula. Or let's not use vertex form. Let's be using the vertex formula. So what does the vertex formula say? Let's just use what I taught you in class. Vertex formula says the x coordinate happens at negative b over 2a with all of these letters, right? So we know that x coordinate is 1, right? So we know negative b over 2a is equal to 1. So that means we know that negative b is equal to 2a, or b is equal to minus 2a. Does that make sense? So we can actually rewrite our formula down here as we can replace b by minus 2a. So we know we have y equals ax squared minus 2a x plus a c. And then probably what we can do is plug in both points, and we'll have 2 equations and 2 unknowns, is my thinking. Let's plug in the y-intercept. That'll tell us what c is, I believe. So if we plug in -5 for y, these first 2 terms are 0, so we'll have 0 minus 0 plus c. So we know -5 is equal to c. So that tells us our equation really looks like y equals ax squared minus 2ax minus 5. Yes? So this was plug in y-int. So now we're going to take this equation and plug in the vertex. So we'll have -3 is equal to a times 1 squared minus 2a times 1 minus 5. So plug in vertex. So then we have -3 is a minus 2a minus 5. So we can add 5 to both sides. So we have 2. And then a minus 2a is minus a. So -2 is equal to a. So if you take this equation now and replace the a's, we get y is minus 2x squared. And then -2 times -2 is going to be plus 4x minus 5. Sheesh, that was trickier than I thought. And I've done this problem, sadly. Memory too well. Okay, so that's how we get it. We just use the vertex formula, and we don't have to worry about anything else. It's a little bit tricky in the order to plug in the points, though. So does anyone have any questions on that one now that we've finished it? Sorry that I was so forgetful. Okay. Write an equation that defines the exponential function with base a greater than 0. Base a greater than 0 would be this one, a. What's the domain? Well, the domain of all exponential functions is all real numbers. So we would go from negative infinity, it's probably a symbol, up to infinity. Whoops, too many parentheses. If a is not equal to 1, what is the range? Well, they normally start, they have the x-axis as an asymptote and then go all the way up to infinity. So it would be from 0 to infinity. Okay. And then the graph, we went over the two possible graphs. It says a is greater than 1, so it's exponential growth, which is this option. If it's between 0 and 1, it's exponential decay, which is this option. They show you a bunch of other ones that don't work as well, but that's it. So just checking your properties of exponential functions there. Okay.
Wait, what was the equation for that one?
What do you mean?
At the first question. A to the x. Okay, thank you.
Yeah. But yeah, if you go back in your notes, that's exactly what we looked at. So this one, number 4, would just be the exponential function that's shifted down 4 units. Again, if you're not sure, you can graph this in Desmos. So I'm not going to show any more details on number 4, how you can figure that out. Simplify the following expression, checking some rules of exponents. So remember, on this one, you just add the exponents. So this would be x to the 9th for my numbers. And the next one, you would subtract the exponents, right? So 5 minus 3 is 2. So this would be squared. Nothing too difficult on 5 or 6. Okay, this one I'll leave it to you as well. Remember, linear functions will have it's a fixed additive change for x. It's going up 1 every time. So linear, you would have a fixed additive increase, and exponential, you would have a fixed multiplicative increase. And that multiplicative increase would be your base. So number 7 shouldn't be too difficult. Let's look at number 8 though. Under ideal conditions, a bacteria is known to double every 3 hours. Suppose there are actually 200 bacteria. What is the size of the bacteria after 12 hours? So number 8 here. So double every 3 hours. You can kind of just think of like so we start at 200 at hour 0, let's say. So after 3 hours, it would double and be 400. After 6 hours, it would double again, be 800. After 9 hours, it would double and be 1600. And then after our 12 hours, it would have doubled one more time and been 3200. Okay, what's the size after T hours? So this one's a little bit trickier to think about, but this is acting like our T, and this is acting like our, oops, not very good. This one's acting like our T essentially, and this one up here is acting like our P of T, our population. So we know P of T is equal to 200, our initial, times some a to the t power, something like that, right? Well, we can figure out a by just plugging in one of our numbers, right? We could plug in 3 for t and 400 for p of t. So say 400 is equal to 200 times a to the third. So you could divide by 200 here. So we have 2 is equal to a to the third. And then to solve here, you would take the cube root or the 1/3 power of both sides. So 2 to the 1/3 would be a to the third to the 1/3. So basically 2 to the 1/3 is our value of a. So our exponential formula, if you will, is P of t is 200 times 2 to the 1/3 raised to the t. Now this would typically be written as 200 times 2 to the t over 3. But the thing they're asking for is what is the size after t hours? So they're really just asking for a formula here. So we're going to say 200 times 2 to the 3. Get the size after 20 hours, you just plug 20 into your calculator. 20 in for t, rather. So that would be nearest integer, does it say? On my numbers, I got 20,319 if I do nearest integer. And then graph the population. Well, 2 to the 1/3 is still a number larger than 1, so it should be exponential growth. Again, it's either, it's one of the graphs on the right. Do we have any numbers that make sense for us? After 20, we just plug that in. After 20 hours, we got about 20,000. So we should be at a height of 20,000, which looks more like this graph here. Estimate the time for the population to reach 60,000. So let's try that one. We would have 60,000 replacing P of t, and that would be 200 times 2 to the t over 3. So we divide by 200. So we get 300, I think. And now we have to use our logarithms to get that t out of the exponent. So take the natural log of both sides. So natural log of 300 is t over 3 times the natural log of 2. I mean, you can do approximations here if you want. So something like 5.7038 equals t over 3 times 0.6931. So again, divide that by 3. We get 5.7038 equals 0.2310 times t, and then just divide by 0.2310. And we get t is like 24.7. Okay, so yeah, got them all right. Any questions there? A little bit tricky at the end. Okay, so this is find the exponential function through 2 points. We did several of those examples, but I will do one more. Remember, for this one, we just basically say y is equal to, let me do it over here. Y is equal to a times b to the t. So you just plug in both points and plug in the larger x value first was my recommendation. So we have 375 equals ab cubed, and 15 equals ab to the first. Then you take ratios. So we get b squared on the right and 25 on the left. So when you take the square root, we see that b should be 5. And then we know that our exponential equation looks like y equals a times 5 to the t. So we just want to plug in one of those points. Let's plug 1 and 15 in. So 15 for y 1 for t, divide by 5, and we see that a is equal to 3. So our function is y equals 3 times 5 to the t. Oh, did I mess something up? Okay, so 15 for y, 1 for t, that's correct. Oh, x. I just used the wrong letter. I was using t, they were using x. Oh yeah, I gotta pay attention to that syntax. Sorry about that. There we go. Okay, this is a multiple choice one, so I'm not gonna go over this. Find the exact value without using a calculator. Remember, you just have to ask 2 to what power makes 16. We know 2 to the 4th power makes 16. So if you would flip over the fraction, remember you get reciprocals if you do a negative power. So this one's asking 4. So 4 to the second makes 16, which would mean 4 to the negative second would make 1 over 16. So that would be minus 2. Any questions so far? Let me check the chat, see if there's anything in there. Where can we find the recorded lectures? I'll post those. So if you go to just the Canvas page under Home, they're all available. So let's see. If you go to our page, I gotta go to the full page here. If you go to our Canvas page, Applied Calc 1, it's just under the Home tab. So let me go to Student View. It's under the Home tab. So I've got all these listed right now. I'll put up the homework number 2 one as well. But yeah, another thing you can do is this just takes you to my YouTube page. So if you go to, you can subscribe to my channel. That might make things easier. But if you go to my channel, you can go to playlists and you can find the Math 1044 playlist. And, you know, here you can see pretty much all the videos I have. So you can find videos for other things. Like I said, here's homework number 2 questions. I'll post the video from today and the WebEx is from this week as well. So I have this recorded but not posted yet. But essentially, that's how you find the videos. So I hope that answers that. Any other questions? Will homework number 3 be due on the 2nd? No, definitely not. I'll push that back. So I mean, I can do that now real quick. It'll be at least a week further in the future. So let me I'll just make it February 9th or something for now, but next week is the 5th. So yeah, the 9th is fine for now. That'll be the earliest it'll be due. I have to see what sections are on. So yeah, that was incorrect. Like I said, the assignments were set up on a different schedule. So sorry about that if you're worried about homework number 3. Definitely not that soon. Okay, so back to the homework here, which is on this tab. Okay, find the exact value. These are inverse properties. These are pretty easy. The natural log just cancels with the e, so I'm going to get 6 and 8 here. I'm not going to write it in, but you just get the exponent here, and you get the argument of the logarithm here. At the end, we get some properties, so that's, you know, a little bit interesting. So number 13, we have the natural log of 4 plus 7 natural log of x, and they want us to write as a single logarithm. Excuse me. So we have natural log of 4. I'm going to leave that alone. The 7 I'm going to put back in. So this will be the natural log of x to the 7th. This is by log property number 3 in our notes. And then you can combine them via multiplication. So this will be the natural log of 4 times x to the 7th. And that's by log property number 1. Oops, careful with the parentheses. All right. Number 14, we're doing the same thing, but we're going to have log property number 2 since it's subtraction. So 8 natural log of u minus 2 natural log of 5. So put them both back in, the numbers in front as exponents. So this will be the natural log of u to the 8th minus the natural log of 5 squared, which is 25. So this is by log property number 3 again. And then we have the natural log of u to the 8th minus the natural log of 25. And then we can put this together as one big fraction, u to the 8th over 25 by log property 2. Works. Yep, absolutely. And then we've got the last two, which are just solving some equations. Number 15 is really easy, so I'm going to skip that one, and we'll go to number 16. Notice you can use decimals here. You just have to round to 4 decimal places. So you want to keep a lot of decimals as you work these out. So number 16, we have 5 to the x minus 7 equals 4. So I'll take the natural log of both sides. And then I'll bring the x minus 7 in front. I'm going to go ahead and just figure out what those logs are on my calculator. I'm going to keep, let's say, 5 decimal places just so I don't have any errors when I'm rounding. If you do, you're probably just off one way or the other. Okay, so then I need to multiply through. So I've got this big number, 1.60944x, and then I need to multiply that by 7. Normally, like if I did a handwritten test, this would just be, I always say round to 2 places. That way we don't have to keep so many dang decimals. But the online software is making you be a little bit more precise here. That's okay. So we just add this number. So almost done. We have this 1.60944x equals 1.38629 plus 11.83308, which gives me 13.21937. Last step, just divide. And that should give us our value for x. Again, they just want 4 decimal places. So I'm getting 8.2136. So let's see if that works. Oh, sorry. Something went wrong. Were we off? Maybe when usually it's due to rounding or something in the calculation. Let me here. I'm gonna just go ahead and figure out. 1 second. Yeah, I clearly did something wrong somewhere. The correct answer should be 7.8613 or 14. Yeah, what did I do here that messed everything up? See, usually I don't use decimal approximations when I do these. This looks right still. Let me just make sure I did the 1.60944. That's right. Natural log of 4 is also 1.38629. That's true. So let me check 1.60944 times 7. Oh, so that's the error. Sorry, I found it. I did this number times 7 wrong. So this should be more like 26608. 11.26608. Sorry about that. Again, that's another frustrating thing when you're working with things that are so precise by hand. It can really cause some problems. You touch one button incorrectly and messes up the whole answer. So when you add these two together, you get 12.65237. And then when you divide by 1.60944, you get 7.8614. Okay, sorry about that. Got lost in the weeds there for a second. Yeah, so a few more to do. Number 17 is pretty easy by comparison. Why is number 17 easy? Well, we can just use the common log since it's a base of 10. So if you do the regular log to both sides, you would just get 9 minus 8x by the inverse properties. Then you just have one number to plug into your calculator. Remember to use the regular log and not that natural log. So 4 places, 1.6627. Take away 9. So we get minus 7.33724. And then divide by -8. So you get 0.9172. So not as many decimals to fuss with on that one. Number 18, we're dealing with one in the continuous form. Let me just check the chat. Is there any questions? No, not yet. Okay. So on number 18, we have 470 e to the 0.18 t equals 1500. So on this one, it's helpful if you divide by the 470 before taking the natural logs. That'll just make things a bit easier for you. So I'm going to start by doing that, divide by 470. So I just have the e to the 0.18t. So I don't know, I get 3.191489, something like that. Now we want to take the natural log of both sides, because that'll cancel out with that exponential function, and you'll just be left with 0.18t. So on the left, I have 0.18t. On the right, I have something like 1.16049. And then when I divide by 0.18, I get my answer. Which is 6.4472. Okay. We actually did number 19 in class. So if you look at the notes from last class, we should do that one. Basically, you just set P of t equal to 1,000. That's the trick here, because the population is modeled in thousands of people, and they want to know when will the population reach 1 million. And 1 million is 1,000 thousands. So you just set P of t equal to 1,000 and then solve this equation. So we did do that one in class. Okay, so this is one we looked at earlier, where we have the bacteria population doubling every 3 hours. This time it's starting with 100. I think before it was starting with 200, but we get this equation. So it's saying, when will the population reach 60,000? So again, I'm not going to do that one either, because we did that problem if you look all the way back at number 8. So number 8 at the end, we started with 200 and we asked when would it reach 60,000, and we did exactly that problem. So number 20 is very similar to part D on number 8. So that's pretty much it for homework number 2. Does anyone have any questions for me?
Could you go over? Hold on 1 second. For number 8, could you go over part A and B really quick?
Sure. So what's the size after 12 hours? You just have to double it 4 times, basically, right? So it says 12 hours, right? And I know it doubles every 3. So I just doubled it until I got to 12. And I got 3,200. Double 400 times 2, 800 times 2, 1,600 times 2, 3,200. Once you have the equation, you could also plug it in there, right?
Yeah, I was gonna ask about for part B. Where did that 2 come from? Just by doubling it?
No, we solved for 2 right here, right? So I have P of t equals 200 times a to the t. I'm plugging in this first ordered pair, 3 comma 400. So 400 replaces P of t, and 3 replaces the t in the exponent. And then when you divide by 200, that's where you get the 2. 400 over 2 is 2.
Okay. All right, thank you.
Yeah, you're welcome. Anyone else?
Can you go over D1 and D2 for number 3?
For what number?
Number 3.
D1. Okay, D1. So remember, if you look at our notes from exponential. So these were the notes we had on the exponential day. We did the 2 possible graphs. So if the base is bigger than 1, it looks like this. If the base is between 0 and 1, it looks like this. So that's all you
Okay.
need to know essentially. So if you go back, it says if they're using A instead of B here. If A is bigger than 1, it should look like this one. Part C right here, right? Because it's growth. And if it's between 0 and 1, it should be decaying. So it looks like this one. So it's
Thank
just
you.
2 pictures from the notes. Any other questions? Okay, I'll go ahead and stop the recording then.